And here we're going. So let's get max up. I have to warn you, I've recently changed to max 7, so I don't necessarily know what all the quick buttons are, so I may do things by a little bit of a straightforward way of doing things, rather than use some of the shortcuts which are more appropriate. In particular, there's a few objects I don't know where to find on the shortcuts around here. Okay, right, fundamentally this is max MSP, and what you do is that you have boxes that do things. So I'm going to make an object. This object is going to be called print. Now, built into max MSP, there are quite a few of these objects. I can move them around, arrange them, and print by itself isn't going to do very much. What I'm going to do is bring up an extra window, which is the max console, where all sorts of interesting little status messages and things come out. I'm going to put that there. If I can actually send a message into this inlet, okay, then that message is going to appear over here. And that allows us to look at some of the very basics of max MSP. One of the types of messages that we can send is what's called a bang. Now this here looks like a little button, and it is. And what's going to happen, I won't just connect it up just yet. I'm going to go out of edit mode into, well, I don't know what it's called, performance mode, lock mode. You see I can push the button, but nothing's happening over here. This little button sends a message of type bang, but it's not going anywhere. So what I'm going to do is say that if a message is sent out of this button, it's going to be sent to the print box, which means I click the button, the message goes down the cable into the print box, and the print box thinks whatever I get, I print in the max console. So there we go, click, and there is bang appearing over there. This is the basic concept of max MSP. It does get more complicated, but you have objects which can create messages of some sort and send them to other ones. Right. As well as having a bang button, I'm going to use the shortcut I for an integer box. Okay. What the integer box does, it means that I can type in an integer such as 10. If I hit the return key, the 10 travels down here, gets to the print box, and appears over here. Right, now what can we do? Well, I can put different numbers into there, and every time I hit return, a message comes out. If I click on the number box, this is an integer box, and then click and drag up or down, it sends out loads of numbers. So every time I'm dragging up and down, you see the numbers changing very quickly, and you can see that absolutely loads of integers are coming down this line, hitting the inlet of the print box, and the print box decides what to do with them. We can have other types. I'm going to go Control, click on the back to get into edit mode, and over here I can put F for a floating point box. These are different types of messages that are being sent: a bang, an integer, and a floating point. And once again, I can enter my floating point, 3.72. There it is appearing over there, or I can click and drag. Another type of message is actually the message itself, M for shortcut. And I can put something in here, like, for example, Aria Pro 2. Okay, and that's going to be a message. I connect it up to the print box, go into Command click to go into lock mode, and I can bang the bang button, and the bang goes down to the print box and gets printed. I can put an integer in, comes out here. I can put a floating point in. If I click on the message box, it actually sends that message, Aria Pro 2, down the cable to the print box, and it comes out there. Now, print boxes aren't very interesting. So what else can we do? This is one of the shortcuts I don't know. It's a K slider. Right, that looks like a keyboard, and looks like we're getting more musical. I'm actually going to connect that first straight to the print box. And like all the others, I'm going to clear this console. I can click on the keys, and it does things. What it's sending is appropriate MIDI note numbers. I won't show it in this first little video, but you can actually open this up and change things like effectively transpose the keyboard, etc. But it's quite useful because you can see I can hit a key and I get a MIDI note number. Let's start doing something a bit more musical. I'm going to disconnect that from that, and I'm going to get rid of all of that. Select and backspace. What I want to do is I'm going to make I'm not going to do that. I'm going to make a little integer box so we can see the integers coming through it out. Every time I hit a key, it sends a MIDI note number as an integer down here, which comes into this integer box. If I want to, I can now make a new box, and I'm going to go plus 20. I can connect the output of the integer into the plus 20. This is a plus, it's addition, and it's adding, at the moment, 20. I can then make another little integer box down here, and I can see what happens. Right, click, and you can see that a MIDI note number comes out of the keyboard object, goes into the integer box. If a number comes into the integer box at the top, the same number goes out. So in actual fact, the number is traveling into there, we can see it, but it immediately travels out of there, into the plus box, gets 20 added to it, comes down here, and if 45 has come into there, 65 comes out. You can see that this box is processing the signal or the message that it receives. Actually, this is a bad choice of word signal. Don't listen to that, because we can actually make audio. Right, what else can I do? Well, I'm going to do the MTOF, and that stands for MIDI to frequency. So I can take a MIDI note number from that keyboard and turn it into a frequency. That frequency is going to be a floating point, so I'm going to use a floating point box to show it. Now if I play my MIDI note numbers, you see the MIDI note number comes out as an integer, as appears there. It also goes through the MTOF box. So a message comes in the inlet of an integer, what goes out is the corresponding frequency. If I want to, I can do all sorts of things. We can open help, reference, inspector, if I want to change things. Not a lot, actually. I can change the appearance, etc. Text color, font size, basic, recent, all. Okay, I'm a bit disappointed. Oh, here we go. I can change the frequency down here. I was about to say I was a bit disappointed. So let's make it based on A above, middle C being pretty much 441 Hertz. Okay, so if I start playing the A's, oh, I'm going to be in lock mode. If I start playing the A's, one of them should be 441 Hertz. Okay, so I can play around with these boxes and make them do interesting things. This is just sort of meant to be a very light introduction, just to show some of the basic concepts. What can we do that's interesting? I should have thought of something perhaps before I started. Okay. Well, I'm going to do what is mentioned. N is a shortcut for making a new object. So N, I make a new object, cycle tilde. Now this is a different type of object. Let's get rid of the inspector, I don't want that. This object here is a sine wave generator. It has a frequency which comes in, see signal float frequency, and I can connect the MTOF. I'll get rid of some of the things I don't need, like all of that. I can connect the output of the MTOF box into the input of the sine wave. And this is another shortcut I don't know. EZDAC is an audio output. The way I'm creating this movie, you won't be able to hear much of the output of the sine wave. But you might be able to hear a little bit coming out of my speakers and back into the Mac microphone again. Okay, go into lock mode, and I can actually turn audio processing on and off. Something is coming out, I can see it, can't actually hear it, and that'll be because my audio status, my output. Okay, well, okay, quite surprised I couldn't hear anything. I can't hear anything either. It's not just it's not being picked up by the microphone. Okay, well, this movie is what it is, and I turn it on. Oh, now I can hear it. Okay, so what I'm going to do is just do a little bit of synthesis. So that'll be the end of this. And if you want to know more, ask questions. But this is very, very basic here. Okay, what am I going to do? Think. Okay, what I'm going to do is I'm going to have 2 cycles. Alt key allows me to drag a box away to make a copy. And what I'm going to do is times 3.0. So the frequency which comes out is going to be multiplied by 3, go into the second cycle, and then going to not put that sine wave straight to the speaker, but mix these two together. So I'll have one sine wave which is 3 times the volume of the other. The first thing I want to do is I want to have this one, which is a harmonic, be a bit quieter than the other. So times tilde. Now why is there a tilde there? I'll explain that in a second. This one's going to be multiplied by 0.3. And this one here, 0.7. So the fundamental's louder than the harmonic. I then need to add these together. Effectively mixing them, because otherwise they are separate signals. And finally that goes to the speakers. Now I need to explain these tildes because they're quite important. Up in this part of the patch up here, what's being passed around are messages. I click on a key, get out of edit mode, I click on a key, and a single number comes out of here. That single number comes out of there. It goes in 2 directions. Effectively, it's like it gets cloned or something. We've got the single number that comes out of MTOF, MIDI note number to frequency, will go straight to the cycle, through the times 3, and to that cycle as well. So whatever frequency comes out of here goes as a single number into there as itself, and into there at 3 times its frequency value. The cycle produces a signal. There's actually audio going down these little spotty patches, little spotty patch chords, or dashed patch chords. Because it's a signal, I can't just use the straight multiply or add. I've got to use one that knows that, hey, you're getting an audio signal and you've got to process it. So it is a multiplication, but the multiplication tilde means I'm processing an audio signal. So you can see that this part of the patch, after we've gone through the 2 sine wave oscillators, is actually generating audio signal. I am taking the audio signals, the 2 of them, 1 sine wave and 1 sine wave, 3 times the frequency, and I'm multiplying them by values. That effectively changes the volume. If I multiplied it by 0, it'd make it silent. If I multiplied it by 1, the volume would be unchanged. If I multiplied it by 4, the volume would be considerably increased. 0.7 means I take the volume down a bit. 0.3 means I take the volume down quite a bit. I then add those 2 together. Adding of signals is mixing, and the mixed signal I'm sending to both left and right inputs of this audio output. So let's turn that on. And you can hear it's got a slight square wave sound. I'd had to add quite a few more sine waves before I got anything like a square wave. But you can see it's very, very simple, but basically the concepts are you have objects. Objects, when you interact with them or things happen, go all over the place. Sorry, objects, when you do interact with them or something like that, will send messages around. It's a Friday evening. I'm not doing a particularly well-scripted job of this. And some of these objects will send messages, and some of the objects will produce an audio output stream. And by patching them up how we like, we can get interesting things. So what I'm going to do, just to finish this off, I'm going to show another couple of interesting objects. A toggle button is actually something which you can turn on or off. What it does is actually simpler than it might appear. All it does, if you turn it on, a 1 comes out the bottom. If you turn it off, a 0 comes out the bottom. And that can be used to control objects. One of the objects it can control is Metro. A Metro produces bangs, the same way we had a bang button that can produce bangs, and the toggle, the 1s and 0s, will turn this Metro on and off. Once it gets turned on, 250 milliseconds, it produces 4 bangs a second. I'm going to produce a new object, which is a type LED, so that we can actually see the Metro working. So, every time the Metro produces a bang, 4 times a second, the LED will flash. Okay, so there it is flashing. Okay, well, what can I do with that? Why am I doing that? I want to make something musical out of it. Sort of musical anyway. So what I'm going to do is I'm going to have a random object. And the random object has arguments, range and seed. I want it to be a range of 24 for 2 octaves. Every time a bang comes in the inlet of the random, a random number between 0 and 24 will come out. I'm going to connect that up to a print. So every time the toggle button turns the metronome on or off, if I hit the toggle button, 1s and 0s will come out. If I hit, a 1 comes out, turns the metro on. Switch it off, a 0 comes out, turns the metro off. Okay, it's very, very simple. The only real connection between these is that produces 1s and 0s, and that knows what to do when it receives a 1 or 0. It doesn't know it's come from a toggle button. Could have come from anywhere. The metro starts producing 4 bangs a second, go into the random object, and the random object is producing these random numbers over here. There we go. Okay, so what I could do then is, these numbers are all between 0 and 24, so as MIDI note numbers, they're pretty rubbish. So I'm going to add 48 to them. Okay, I'm going to expand that a little bit. And now, down the bottom here, I'm going to have something which looks like reasonable MIDI note numbers. Okay, so there are my reasonable MIDI note numbers that will sound reasonably pitched. Right, all I'm going to do is take the output of that and put it into the M2OF. Okay, we can connect any number of things into an input that we want, and we can connect outputs to all sorts of different places. In this case, we'll get a note whether or not it came from the metro, or came from this sub patch over here, or it came from the keyboard. As long as a number goes into there, it will be turned into frequencies and then used to control the sine waves. So let's see what happens. Okay, I hope you can hear the sound. Oh dear. You see, it still works. If I hit the keyboard, a single number goes into there, comes out as a frequency. And if I turn the randomness on, okay, if you learn anything like Max MSP, I don't recommend you try and learn it all at once. In actual fact, I think for a first video on Max MSP, if this was specifically designed for one, I would have actually covered too much. But I think there's a little bit there, and I hope it makes some sort of sense. Fundamentally, you can see of these different patch cords connecting things up, I can make objects do things, and by wiring them up in the right way, all sorts of interesting things can happen. Okay, well that's enough for this one. So thank you and goodbye.